Hello. All right, let's take a look at one-to-one and inverse. So the three bullet points at the top of the notes, that first one with the function notation reads like I've got here. So if the outputs are different, then the inputs that created those outputs are different. And that is the basic idea of one-to-one. In other words, you have points where none of the x's for all of the points and none of the y's are the same. They're all unique, like that. And if we imagine a graph, this would be the horizontal line. Remember, these are already functions. So they passed the vertical line test, and now we're looking at a specific type of function one-to-one. So they would pass this horizontal line test like that. So let's think about the parent functions that we've dealt with in the past, and some of them are kind of default, not one-to-one. Can you think of them? I'm going to show you three. See, where are the fingers? Where's the camera? Three. There we go. Have you got three or have you got one or two? Here's a hint. Two of them look like letters of the alphabet, and that should automatically get you those two. A third one, anyways. So our most favoritist function of all time, all semester, quadratic, quadratic, quadratic. Can we stop with the quadratic? No, we cannot. They are super amazingly in everything like that. Looks like the letter U. Draw a horizontal line, you touch it twice. Absolute value looks like the letter V. Horizontal line, touch it twice. And the third one would be the rational function 1 over x squared with my big head in the way. So everything is positive. That's one of the characteristics of these parent functions is that all of the range are positive numbers like that. Now there's lots of other functions that are not one-to-one, but we're just talking about parent functions right now. Let's think about how we could take these parent functions and we want to make them one-to-one. We're going to need to restrict the domain. One of the things that you want to do when you do that is you want to keep the entire range intact, because we could restrict the domain in an infinite number of ways, but we want to keep the full range intact. And there are two ways of doing that. We just cut them in half. The parabola and the absolute value, we would call that point the vertex. The rational function, that would be the vertical asymptote there, like that. There you go. All right, so for the next part, what about the parent functions that are one-to-one by default? And I've got a couple of them. There are actually four parent functions, but I only got room for three, so sorry about that. So the cube, go back to our polynomials. We could have done a straight line. I like the cube as the parent function better than y equals x, but obviously y equals x is one-to-one as well. The roots, even or odd roots, and I'm only going to show you the square root here, but all of the parent roots, even or odd, square root, cube root, they're all 100% one-to-one. And then we've got the rational function. Sometimes this is called the reciprocal function. 1 over x, it's not squared, so we've got positive, negative on the range like that. Alrighty, I think that's the end of page 1. I'll see you in the next video. Where's the thumbs up? There we go.